So there's the pressure in the tanks, in the oxidizer tanks, which is what was causing the issue earlier, and we have nominal pressure on all oxidizer tanks. There are 4 oxidizer tanks and 4 fuel tanks, so a pair in each pod. All tanks are at nominal pressure. We have not yet enabled the thrusters on pods 2 and 3. We do have the thrusters on pods 1 and 4 enabled, but we will be enabling the thrusters on quads 2 and 3 shortly, and we expect those to operate well because the tank pressurization is at nominal levels.
Philip Sloss with NASA Spaceflight.com. For Mr. Suffredini, can you talk about sort of the bounds for berthing opportunities? How soon? What's the earliest you could do one, and what's the latest that Dragon could do this? And then for Mr. Musk, can you elaborate on the sequence post second stage separation in terms of what happened with charging the RCS system when you saw that was it post-SEP, or were you seeing some indications before on the way up? Thank you.
Let's see. Generically, I haven't looked at the specifics yet. The team has been focusing on in providing support and being prepared for tomorrow if that was possible. And so now we're going to work the options. Generally speaking, we have a number of days for the Dragon to berth. The next operation that's restrictive of Dragon operations around the ISS is the departure of the crew, and that's the 15th of this month. And so we have to protect a couple of days around that, and so we have a number of days to protect on this side. On the back side, we've become a little more constrained. We don't have as many days in a row for unberthing, but because we have flexibility in the life of the spacecraft, we'll find a happy spot between the berthing date and an unberthing date that meets the research needs and the Dragon requirements.
Let's go ahead and take one more from Kennedy Space Center, and then we'll go to the phones. Mike?
Spaceflight now. Just a couple of questions. One for Mr. Musk, perhaps. From a Dragon perspective, how long can Dragon loiter in orbit in a solo flight mode before you have to make a decision to berth or come home? And also, what is the contractual situation with cargo delivery if NASA doesn't get comfortable with the thruster situation? Are we looking at a reflight, or what's the contractual requirement for the next step? Thanks.
Sure. So Dragon's actually capable of being on orbit for several months in theory, because it's got the solar panels that are charging the batteries, and so it's capable of being up there for a long time. We wouldn't keep it up there that long, but I think we would keep it up there for at least, I think, a month at the least, trying to sort out any issues and make sure and get everyone comfortable with an approach to the space station, assuming that's looking good. So I think it's going to be up there for a while, come what may, and we'll be doing the perigee raise burn quite soon. And then with respect to contractual things, if we don't get cargo to the space station and then get it back, we get partial payment for the mission. So I don't have the exact numbers in front of me, but it's essentially we only receive partial payment.
Okay, Kelly, let's go to the phones, please.
Thank you. If you would like to ask a question, please press star, then 1. The first question is from Jason Parr. Your line is open.
Hi. Would you like to know if you guys get comfortable to the point where an approach to the station is allowed, are there contingency plans for a thruster failure inside the safe zone? And in particular, would there be any work done from the astronauts' point of view that are on station?
I'll take that one. So we won't allow that. We have rules that say what the required minimum redundancy is that is necessary to enter inside the ellipsoid, and so we won't be waiving those for this case, what I suspect will happen is we'll convince ourselves that the system is healthy and the redundancy is there that we require. So that would be the approach we'll take. So it's not our intention to waive safety requirements inside the ellipsoid to get the Dragon there, rather to convince ourselves the systems are healthy and we have the required redundancy.
But even with that redundancy, if something were to happen inside the ellipsoid, is there a contingency plan?
Absolutely. We have back-away plans for failure modes. Of course, we require 3 of 4 quads to approach the station, and that actually gives you the redundancy so that if you have a failure, you can still back away, and that's what you do in that case. Of course, if you have 4 or 4, then that gives you an option to keep coming if you have a problem as you enter inside the ellipsoid. So the Dragon itself is actually, in a lot of cases, more redundant than is necessary to allow us to continue the approach as we come inside. So we have plans for every failure mode you could imagine. We've talked it over with SpaceX. We have plans. We've simulated them, and we follow those rules very closely with our SpaceX partners once you get inside the ellipsoid.
Ready for the next question?
Yes, thank you.
Thank you. Dan Leone, your line is open.
Hi, good afternoon, everyone. Thanks for having the call and for keeping us all so in the loop so timely all throughout the day. In a worst-case scenario, when you don't make a delivery, what would the effect be downstream for ISS logistics? When would that needed cargo arrive? What's the next opportunity, and what adjustments would NASA have to make in the meantime?
So for every flight, as part of our flight readiness reviews, which we call stage ops readiness reviews, we assess the logistics capability of the ISS without that vehicle, and then we have assumptions for other vehicles that may be coming. We're still in a relatively healthy state relative to having plenty of excess capacity on board the ISS. What we lose with Dragon, if it doesn't show up this time, really is research hardware more than the type of normal logistics things that allow the crew to stay on orbit longer. But even with that, we have research on board that will take us well into the summer. In fact, I'm trying to remember off the top of my head, I think we actually can get into September with the research we already have on board. Now, the significance of the loss would be the type of research we had planned for this specific flight. And while we will do research on ISS if Dragon doesn't show up, we have some specific research we were trying to get done, and so we would have to repeat that on a later flight if it turned out Dragon couldn't have made it. But as far as maintaining the vehicle and the crew, the Dragon itself did not bring that much in the way of those kinds of logistics, food and clothing and water and all those things that allow us to keep the crew on orbit.
Thank you.
The next question is from Marcia Dunn of the Associated Press. Your line is open.
Thank you. For Mr. Musk, I'm wondering, is it conceivable that you could rendezvous on Sunday or even Monday? And this is the first Dragon flight to have such serious trouble, and I'm wondering if there was a sense of dismay or alarm as you were dealing with this problem.
Sure. It's difficult to comment on an exact timing for potential berthing with the station, because that really depends on us taking an exhaustive look at the data, working through that with our partner NASA, and making sure everyone's feeling comfortable. So we're definitely not gonna rush it, and we want to make sure first and foremost that things are safe before proceeding. With respect to alarm, yes, absolutely. It was a little frightening there. One point I should make, though, is that, and Gwen made this early in the press conference, is that the Falcon 9 rocket performed its job super well. I mean, it did absolutely nothing wrong. So the Falcon 9 rocket, performed really perfectly. And I noticed some of the press headlines sort of confused the rocket with the spacecraft, and I don't want to give assign blame unfairly here. The rocket went really well. So for the spacecraft, we noticed after separation that only one of the 4 thruster pods engaged, or sort of was ready to engage. We didn't turn it on, but it was ready to engage. And then we saw that the oxidizer pressure in 3 of the 4 tanks was low, and so we spent the last several hours trying to fix the problem, and we think we have, and if that's the case, it's certainly going to be a huge relief, and we'll be really glad to do our duty for NASA here, and hopefully and be able to deliver the cargo that we intended to deliver. I can say that we're not. There's no leakage or anything like that. There's no debris or fluid or gas leakage that we're aware of. So all systems appear to be intact and functioning quite well at this point. So hopefully things keep going in that direction.
Thank you. So it sounds like the weekend's off. I mean, that's pretty clear that there's nothing going to be happening in the next few days regarding a rendezvous.
Probably that's probably the case, but we've only just brought things back online, so it's difficult to say with certainty what will occur when.
Thank you very much.
Marcia, don't go to sleep on us over the weekend.
Exactly.
You read my mind. Thank you.
Not jealous of you then if everything else, if we can convince ourselves the data's good, I suspect we can find an opportunity on Sunday. But again, we have to go look at it. So.
Okay.
Yeah, exactly. That would certainly be our aspiration, if possible. Yeah.
All right. Thank you.
The next question is from Irene Klotz of Reuters. Your line is open.
Thanks very much. I had a couple questions, I think, probably for Elon. How much time did you buy in deploying the solar arrays, even though on your Twitter post you seem to indicate that you were going to wait until at least one more thruster pod was recovered before that would be attempted? And then on a general note, I was curious if this had been a crewed flight, what would be the implications for any astronauts aboard with this sort of problem? Thanks.
Sure. So at first we were going to get 2 thruster pods enabled before deploying the solar arrays, but then we noticed that the temperature of the actuators in the solar arrays was dropping rapidly, and we thought, well, it's so we ran a control analysis of the spacecraft, and it's actually kind of in a sense sort of obviously if you think about it, it's kind of like if you're a skater and your arms are close to you versus you hold your arms out, it actually slows down the rate of rotation if you extend the solar arrays. So actually that turned out to be a good thing. So we extended the solar arrays and just made sure that they were operational and stopped cooling down because they're going to a very very cold temperature. So that was the reason there. Sorry, what was the other part of the question?
How much time did you buy as far as battery recharging with the arrays out, and then if there had been a crew aboard, if this had been a crewed SpaceX flight, what might we all be talking about now?
Sure. Actually, in terms of battery time, we had at least sort of 12 to 14 hours of battery life. So it wasn't a question of running out of energy in the batteries. It was more a question of just making sure that the solar arrays didn't get so cold that there was some risk of deployment failure. For the crew version of Dragon, we're actually not planning on having solar arrays. We're planning on just having a very big battery pack. So that would alleviate some risk there. And we'd only put solar arrays on if it was for some reason a long duration mission. But for a situation like this, I think the outcome would be quite positive because we can afford to lose up to 2 quads. In fact,